Alright, I'm going to do a video on calculating excess reactant left over, and that's the main goal for this, but I'm going to start from the very beginning. Okay, so to solve this problem, if given 35 grams of H2 and 61 grams of O2, calculate the theoretical yield of H2O in grams. The problem would give you the balanced equation. I just forgot to write it down before I started this video. Well, it'll give you the equation. You may have to balance it. In this particular one, I'm balancing it for you. Okay, using this equation, you would solve this 2 times because you have 2 givens. Okay, so you would take your first given of 35 grams of H2. And this video is designed that you already know how to do this part. It's just the second on calculating excess that's a little confusing. So I'd use the molar mass of H2 for 1 mole. Then I'm going to use my ratio of 2 moles of H2 to 2 moles of H2O that I'm getting from the balanced equation. And I'm going to go ahead and solve for grams. I'm doing that because I know that I'm going to calculate how much excess reactant is left over, and my givens are in grams, so I'm going to need grams at some point. I really don't need it for this one, but it's okay. We're going to practice it anyways. I believe this is 18.02. Now I'm doing it from memory, so if I'm slightly off, don't judge. Got 311.88 grams of H2. Now, with sig figs, because I only have 2 here, I should only have 2 in my answer, so it's really 310 grams of H2O. Alright, now I'm going to take my second given. I'm going to switch colors here just to help. I'm going to take my second given of 61 grams of O2. It's 32 grams of O2 would be my molar mass. Be careful that you don't do 16. This is a diatomic. My ratio for this one is 1 to 2. The 1 mole of O2 being on bottom, 2 moles of H2O to be on top. Anytime you're solving for theoretical or your limiting reactant, your product that you're solving for needs to be the same both times. Okay, the answer I got was 68.7 grams of H2O. Now sig fig wise, I should only have 2, so it's really 69 grams of H2O. Now, only one of these answers is the true theoretical yield, and it is the smaller answer of the 2. So the answer that you would box or circle or however indicate that's the answer on your test would be the smaller answer. That means that whatever produced your smaller answer is your limiting reactant. Now this is critical in order to answer the next question. If that's your limiting, that makes the other one your excess reactant. Your excess means out of that 35 grams of H2, I'm not going to use all that. I'm going to have something left over. So to solve B, to calculate excess reactant left over, we have to figure out how much excess is going to be used with that 61 grams of O2. So to solve this, you're going to take your limiting. So the first thing you have to do is solve for limiting, which is why that was what I did in A here. And we're going to take that 61 grams of O2, and now we're going to solve for how much excess is used with the 61 grams. So to do that, our known would be our 61 grams of O2. Our unknown is going to be some number of grams of H2, because H2 is my excess. I want to see how much is going to be used with that 61 grams of O2. Alright, so started the same way as before. We do my molar mass of O2, 1 mole of O2, and then we do our ratio. Now our ratio comes back up from our balanced equation. Our known is O2, our unknown is H2. They're on the same side of the equation, and that's fine. It doesn't matter. It just has to be 2 things, okay? So I have 1 mole of O2 here, 2 moles of H2 on top. Now I want to go to grams. I know I want to go to grams because my excess reactant amount is in grams, so I'm going to have to end up subtracting those, so I need to go all the way to grams. So I have 1 mole of H2 2.02 grams. So notice that you're solving it the exact same way as before. All we're doing is changing our unknown. We're changing our unknown to be some number of grams of what we have identified to be our excess reactant. Once you plug that in, you get 7.7 grams of H2 used. So when you solve for this, this is how many grams are used when you have 61 grams of your limiting reactant. But you have 35 grams to start with. So to figure out how much is how much is remaining, let me switch colors. You are going to take your original amount, your 35 grams of H2 that you have available to you, and you're going to subtract out that 7.75 grams of H2 that you used to get how much you have left over. And for this case, it is 27.3 grams of H2. Now, sig figs are different when you're adding and subtracting. It's the lowest number of decimal places. There's no decimal places in 35, so technically your answer would only be 27 grams of H2. If the sig figs are still confusing, don't worry about that so much as can you solve the actual problem right now. So just to recap, when you want the excess reactant left over, the first thing you have to do is identify your limiting reactant. To do that, you have to calculate your theoretical yield. You identify your theoretical yield, which is the smaller answer, and then that tells you what your limiting is. You then take your limiting reactant, that is now your known, and you just make your unknown be what you have identified as your excess reactant. When you solve all that, you use your molar mass, you use your mole ratio, everything cancels. You get how much was actually used based on your limiting reactant amount, and then you subtract the original amount you have minus what you used to get what you have remaining. So I hope that helped.